Okay, let's get started. Welcome to the course Introduction to Data Science. I'm the lecturer. My name is Hongshen Chen. Okay, what is data science? I think perhaps many years ago, perhaps like 7, 10 years ago, uh, Zhu Kongwei created this Venn diagram. He said that data science is the intersection of three different disciplines. One is the hacking skills, one is the math and stats knowledge, and the other is substantive expertise. So let's look at this Venn diagram in more detail. So the intersection between hacking skill and mathematics, Zhu Kongwei defined this area as machine learning. So this makes sense because if you know the math, if you have the hacking skill, you know how to do the programming, and if you also know the math details of, for example, logistic regression, linear regression, those kind of things, then of course combine these two together is the typical study field of machine learning. Okay, let's look at the intersection of these two, the math and stats knowledge and substantive expertise. So Zhu Kongwei defined this area as the traditional research. So imagine that you are a biologist. So as a biologist, of course, you have some expertise knowledge about biology. And meanwhile, to do some experiment or to form some hypothesis based on your observations, you have to have some math and stats knowledge so that you could build a model and you could analyze your experimental results. So these two, the intersection of these two areas, Zhu Kongwei defined it as the traditional research area. And interestingly, Zhu Kongwei defined the intersection between hacking skill and substantive expertise as the danger zone. So here's my explanation, which may or may not be the same as Zhu Kongwei's original definition. So my explanation is that if you have the domain knowledge, again, for example, you are assuming you are a biologist, you have expertise on biology, you know a lot of biology knowledges. And then you also have the hacking skill, which means you know how to use the program to plot and how to use, for example, the scikit-learn package to do the linear regression, logistic regression, or those kind of machine learning algorithms. However, you don't have the math and stats knowledge about what's really behind these algorithms. Then it is possible that you can still plot a lot of fancy figures, you can still do some kind of logistic regression analysis. However, if you don't know what's really behind the logistic regression algorithm, for example, then it is very likely what you get is just some numbers, but you just cannot explain how those numbers are derived. So in my opinion, that's why this part is called the danger zone. And the intersection of these three areas, Zhu Kongwei defined as the data science, which is what we will introduce in this course. Okay, so when do we need machine learning? A very critical part of this course is machine learning, but why do we need it? So first, let's compare traditional and data-driven algorithms. So I assume most of you were majoring in computer science or maybe computer science related disciplines. So let's think about a very traditional problem. That is sort of like the algorithm 101 problem. So how to do the sorting. So in your algorithm course or in your data structure course, you should have already learned a lot of different sorting algorithms like bubble sort, quick sort, all those kind of things. And to sort the numbers, we basically tell the algorithm very detailed step how to do if a number is larger than the other, how to do the swapping, how to do the how to change the index, how to do all the kind of things. You have to tell every detail manipulously to the computer. So if you can enumerate all the details, then perhaps this kind of task is more appropriate by using the traditional algorithm. Okay, so for those, if you can really enumerate all the steps, and you can tell that all the steps to the computers, then I think that's more appropriate for the traditional algorithms, not for the data-driven algorithms. But what kind of task is more appropriate for machine learning or for the data-driven algorithms? So they are the tasks that is difficult to solve by the prior knowledge. So for example, if I ask you how to determine a face in a photo, how to find whether there's a face or not in a photo, this seems to be a very simple task for even a 3-year-old children. However, this is very, very difficult for a computer. If I want you to solve this problem, the face determination or recognition problem by programming, how can you do it? So in some sense, it seems that you need to enumerate all the very detailed rules. What is a face, right? What's a eye look like? What's a nose look like? What's a mouth look like? What's an ear look like? You have to tell computers all these details, and hopefully if the computer can identify those patterns, then perhaps the computer can identify a face. But apparently these rules must be very complicated. So in this case, it's really hard to design a face determination or recognition algorithm that works in real life. So how can we do it? We want to solve this kind of problem based on data-driven approach or machine learning approach. So a data-driven approach, or for most of today's machine learning algorithms, they are trying to identify the rules based on examples. So by based on examples, that means that I don't have to tell the rules to the computers. All I need to do is tell the computer which photos has face, which photos have no face. And then I want the computers to identify the rules, the connections between a photo and a face by itself. And if the computers can identify this relationship automatically, then hopefully when I give a new photo to the computer can automatically apply the rules it just learned and then identify whether there's a face or not on this new photo. Okay, so for data-driven approach, what I need to prepare to the computer is, for example, maybe 5,000 photos with face and another 5,000 photos without face. And I just tell the computer, the left pile, these 5,000 photos, they are the photos with faces. And the others, they are the photos without faces. That's all I need to tell the computer. And I hope the computer can learn to differentiate these two piles by itself. Okay, so let's think about it. So basically, this just repeat what I said. So if you want to determine a face in a photo based on the traditional approach, you need to explicitly define the characteristics of a face. For example, what's an eye? What's a nose? Okay, what's a mouth? What's an ear? What's an hair? And how are they arranged? Okay, how are they? What's their internal relationship? You need to define all these details and tell the computer so that computer can hopefully figure out what's a face. And for the data-driven approach, I just prepared a lot of images with faces or without faces, and I basically let the computer knows every one of the photo whether it has a face in it or not. And I hope the computer, after the computer went through all these photos, it can discover the connection between a face and a photo. Okay, so how to do it? Let me give you a very naive approach. I try to convince you that even without telling the detailed rules to the computer, it is possible that the computer can identify the patterns by itself. I just want to use a very simple, naive example to persuade you, but this may or may not really work in practice. Okay, so I give you a photo. Okay, assume this is a 300 by 300 photo, which means the width and the height are both 300 pixels. And let's simplify the scenario even more. Let's assume that this is a grayscale image. So if this is a grayscale image, that means that for each pixel, it contains one value between 0 and 255. Okay, so this is how people see a photo. But as a computer, it just see a bunch of numbers. Okay, so it's 300 by 300. So the computer will see 90,000 different numbers. Okay, so if we collect 5,000 photos with faces and another 5,000 photos without faces, so each of these photos can in fact be represented by a matrix. Okay. Now assume that the photos with faces, they should be relatively more similar compared to the photos without faces. So whenever you are given a new photo and you don't have the label of that photo, without label, that means that the computer doesn't know whether there's a face or not in this photo in advance. Okay, so you are just given a photo. You want the computer to decide whether there's a face in this photo or not. Then one thing the computer can do is just look at the matrix that representing this new photo, and then compare this matrix with the training data. The training data means the photos with face or without faces, we let the computers see through in advance. Okay, so if somehow the computer figure out that the closest matrix to this new photo is in fact a photo with faces, then perhaps this new image is a photo with face. And on the other hand, if it figure out that the closest matrix representing a photo without faces, then perhaps this new photo is a photo without face. Okay? So by this approach, we didn't really tell the computers what's the rule to be a face, but somehow the computer identify the faces by itself. Or maybe I should say the computer determines whether there's a photo in an image or not by itself. Okay, so this kind of data-driven approach is what we are going to introduce in this course. And we have a course website here. We will post most of the static information on this website. And I think after the first week, once you are confirmed you are enrolled in this course or not, then in the future we will announce most of the information on the new EE class. But this week, because some of you are still not officially enrolled in this course, so I need to announce some of the information on a public website. And this is me, and these are the two TAs, and their contact information are listed on this website and also on the new EE class. Okay, so this is a meeting time and place. Originally, we planned to meet at A306, but now, because of COVID-19, I think at least for the first couple of weeks, at least, we will meet online. Okay, and the lecture language is English. Materials. No single textbook is required. However, if you really want to get a textbook that are related to our discussed topics, I recommend these two textbooks. The first one, The Elements of Statistical Learning, it's a very classic textbook written by Hastie and Tibshirani and Friedman from the Department of Statistics in Stanford. And the second book, Deep Learning, this is a relatively new textbook which was published a couple of years ago. And it's written by Yoshua Bengio and one of his students, Ian Goodfellow and Corville. So Yoshua Bengio is, he received the Turing Award a couple of years ago with Yang LeCun and what's the name of the other person? Geoffrey Hinton. Okay, Geoffrey Hinton, Yoshua Bengio, and Yang LeCun, they co-received the Turing Award a couple of years ago because of their fundamental contribution to deep learning. Okay, so this book is written by one of the sort of like the godfather of deep learning research field. Okay, and these two books, they both can be downloaded from the author's website. So you could download it directly. It's not necessary to buy these books. The course material will be a mixture of the slides and notes provided by different books, different instructors, and by me. I may use the whiteboard sometimes, but since we meet online, I might need to use the iPad or perhaps the Apple Pencil to write things. And we have limited experience on this, so let's see. Perhaps we will meet some technical difficulties when we really using the iPad and Apple Pencil. And if that really happens, please bear with us. We hope we could find a good solution, but we don't know yet. Okay, grading. You would have individual grade and group grade, which means in this course you have to have groups. And so for individual scores, you will have individual exercise, which accounts for 55% of your final score. And there's another 5% which in our previous semesters, this 5% is based on your course participation. But now, I don't know how to do the course participation, so I have to think about how to do with this 5%. Okay. And for the exercise part, you will have to write programs mostly in Python 3, and you need to submit your code through new EE class. And sometimes you need to write reports, and they should be typed and submit to new EE class, unless otherwise mentioned. Okay, so that's the individual score. For group score, you will have a course project. It's a group project, and you will need to present your progress in the midterm week, and that accounts for 10% of your final score. And you, at the end of the semester, you have to demo your project, and you have to submit your final report, and that accounts for 30% of your final score. Okay, so let me make it more clear. So for the midterm, you will need to submit the presentation slides, and you will also need to oral present your progress. And for the final, you need to submit 3 things. The first one is your presentation slide. Second one is your typed report. And the third one is your experimental code. Late submission penalty. Okay, so if you really submit your exercise or your project later than the deadline, then here's the penalty. Okay, so 1 day there will be 10% off. 2 days late, 20% off. 3 days or more, then that exercise or that project will be 0. Okay, so we said that you need essentially data science contains 3 parts: math and stat skills, hacking skills, and domain knowledge. And in this course, we will mostly focus on the math and stats and hacking skills, which means that we will talk about how these algorithms works like that and why they works like that. And for the domain knowledge, you will need to propose a final project, and I hope that your final project somehow combines machine learning with some of your domain knowledge. Okay, FAQ. Will the instructor speak only English in class? Okay, so I will make sure that the course contents are in English. If in certain cases I really need to speak in Chinese, I will make sure that I translate to English also. So as a student, do you need to submit the report in English? The answer is not necessarily. You can submit your report either in English or Chinese, but not other languages. So the reason is that the TAs and I, we can understand English or Chinese. So either way is fine for us, but you cannot submit other languages. For oral presentation, the students have to present in English. The reason is that we have some students in this class who doesn't speak Chinese. So you have to present your project in English so that everyone can understand. If you need to ask questions, does that need to be English? Not necessarily. If you really ask your question in Chinese, I can translate that into English, so I can make sure that everyone knows what you are asking. Will the instructor curve the score? The answer is that so if you are undergrad students, 59 becomes 60 and 69 becomes 70, and that's all. The others will remain your original score. Okay, so I know that for undergrad student, 60 means pass. For the graduate student, 70 means pass. So if you get 59 or 69, you will pass. But the others, if you are below 59 or below 69, the score will be what it is. What will happen if you beg for a higher grade? That will be a waste of your time and my time, so please don't do that. If you fake the project result, we will follow the rule of NCU, and you will get 0 for the course. Okay, and in the last couple of semesters, many students were asking for tips for selecting a topic for the final project. And here are some of the tips. You could start from the data set you already have. For example, if you crawl the post from some of the forums, and you could start from there if you have the data already. If you know Kaggle, which is one of the most popular data science competition platform, they provide a lot of open source data sets, and you could perhaps pick a data set from Kaggle and start from there. Because for this course, for your final project, it's very likely that you need to have the data set so that you can start to do a data science project. So so one tip, one suggestion is that you could start from the data set you already have, or start from a open data set. You could also start from something you are interested, or something you have passion. Okay, so one of our previous group, one of our previously related labs, then perhaps you can think about how to combine computer security with data science. Okay, you can start from something you are good at and starting from there. Or perhaps you could participate in some online or offline communities and discuss with them and get inspired. And there are several online communities out there or offline communities out there which sort of brainstorm every month or every couple of months. For example, G0V and Data Science for Social Good. They are some of the very popular and active communities online. And perhaps if you discuss with those people there, you could discover some interesting project, and somehow they can be turned into your group project of this semester. Okay, and here I also list a couple of books which they sort of applying data science to certain domains and trying to fix some problems there. And these books, they happen to have both English and Chinese translations. So I think you could get most of these books from the library. And you can also utilize your semi-finished or ongoing project as part of the final project. But of course, you need to let us know which part is already there before this semester and which part is your work in this semester. Okay, so of course you can combine your hobby project with data science. You could combine your undergraduate project with data science, or you could combine your master or PhD thesis with data science. These are some of the important dates. So your proposal and progress representation will be on the Tuesday on the midterm week. And final project presentation will be 1 week before the final week. And final project due will be on the final week. Key card giving policy. Okay, so because we have only 2 TAs, and if someday we need to go back to the physical classroom, then we have limited space. Okay, so I can only accept about 30 students. Okay, so this is the priority. Okay, so if you are a PhD student majoring in computer science, then you will be in the first priority. The second priority is the senior master students in computer science or in the EECS college. The third priority would be the senior undergrad students in computer science department or maybe double major. The fourth priority would be the junior master student. The fifth priority would be the junior undergrad student. Okay, so you have to fill the form and tell us whether you are a PhD student or senior master student or whatever, and what's your major. And then we will rank the students based on this priority, and then we will select the top 30-ish students, and then the TAs will send the passcode to these students. So you have to fill out the form before midnight tonight, so we could rank the students tomorrow and send the passcodes to you. Okay, I think that's all for today, but before I leave, let me check if there's any questions in the chat room. Sounds like an autoencoder. I'm not sure. Sounds like perhaps you are talking about, I don't know. So autoencoder is something, I'm not sure. I don't think I talk about autoencoder today, but we will definitely talk about autoencoder in future lectures. Books can be downloaded is awesome. Okay. Why there are few students get enrolled cards before the class? I have no idea. That's not decided by me. That's decided by the Department of Computer Science, the office of the Computer Science Department. Is the course all distance teaching in this semester? That is probably the current plan, but I'm not entirely sure. Maybe at some point, if everything looks good, maybe we'll go back to the physical classroom. Can we get the link copy pasted here? What kind of link? I'm not sure what kind of link do you want. Okay, so perhaps you could leave another message so I can answer your question. Next question. So can you just sit in? So the thing is that yes. So we will announce the URLs on the new EE class in the future. It will not publicly available on the internet. It will be on the new EE class. But if you get the URL from your friends, your classmates who really got enrolled in this class, so they should get the notification. If they share the link to you, of course you can join. And in fact, I don't think I have any. I just cannot limit that. So yes, you can sit in. For group report, is there any rules? Okay, so it depends on how many people enrolled eventually. I think 4 people per group at most. And if you want to solo, of course you can do that. The Google form. Oh, so you want the, I think you want the link of the form, right? Okay, so let me paste the, how do I share it? Let me think about it. Let me open the, so if TA is there, could you please copy and paste the form on the chat room, please? Or anyone, please, anyone in the chat room, please copy and paste the URL, because well, right now I'm using 2 different computers, one for presentation and the other just open the YouTube. So it's hard to copy the URL from one computer and pass to another. Okay, so if the TAs are there, please copy and paste the URL. So we have to learn Python before class. Yes. If you have 0 experience in Python, you have to learn it somehow. Where can we get the link of the form for passcode? It's here. Okay, it's here. It's here. But the thing is that currently my slides is on one computer, and but I am currently watching the YouTube on another computer, so I cannot copy the URL from one computer to another. So it's relatively difficult for me. How to do? Oh, so one student was asking if it's always distant learning, then how to find the group members? Well, even in the previous semesters, I didn't really create the rules about how to form the groups. It's always the students finding the group members by yourselves. So I don't know. I think you were saying that if we are in a physical class, you can still physically interact with other people, so you could probably find the group members there. But now, since we are all online, how to do that? Let's see. Maybe, I don't know. I think once you enrolled, you could send a group mail to everyone, right? Is this information correct? If not, then perhaps if you really want to be part of, if you really want to find group members, and you don't know where to find one, then send us an email, and we will probably, if they are like, I don't know, 10 people send emails to us, then we will include all these people into the same mail, and then you probably can find other teammates by yourselves. Okay. If two computers are Mac, it can copy and paste things between them. Well, I have two Macs, but I don't know how to do that. But anyhow, thank you. I'll see how to do that. Okay, so I think that's probably all for now. And if there's no more questions, I think that's all for today. Thank you.